Welcome today to the Tebis CAD/CAM software presentation for Composites UK Meet the Member. Tebis is a CAD/CAM software company specialising in intelligent manufacturing, and also we have a special 5-axis trimming solution which we'll be demonstrating today. So what are some of the business pressures that all of us are under when we're doing CNC and CAM programming? Is that we all have well-established manufacturing processes, but we all wish to grow, maybe improve our facilities. But some of our pressures can also include things like delivery time, our CAM and CNC programming time, maybe some of our efficiencies, and even people's holidays, sick leaves, etc. So can often lead also as well to pressures with the CAM programming difficulty and the workload. But what's really important is we want to try and keep consistent manufacturing processes and quality all the time, whilst ensuring our machine safety and free from collisions. It's very important, very costly otherwise. And also, programming new staff for CAD/CAM can be potentially long training times. So what's the Tebis proposal? Okay, so Tebis is one integrated CAD/CAM package with also quality checking with CAQ, and we have a MES system as well, which is all fully integrated. We have a lot of advanced Toolpath strategies. As I mentioned earlier, we have a specialist 5-axis trimming solution. But one of the things that is very unique to Tebis, again, apart from the 5-axis trimming solution, is our increased machine safety through our virtual machine technology. And I'll be showing you later what's unique about it. Again, we have some unique piece of the software here with its advanced stop model technology. And also we have interactive wizard-based part fixture preparation for cheap fixturing when we're producing vac form parts. But all of this is all encompassed in our intelligent manufacturing. We're going to be building our best practices into our libraries, and all of this will give us these consistent manufacturing processes, quality. It's going to reduce all of our programming lead times, our machining lead times, and it's going to be quicker for getting new CAM staff on board. All of this as well has feature-based technology for machining open and closed surface data, and all of this should reduce your workload pressures and ensure your delivery times. So why is Tebis different? Okay, it's different because of our CNC processes and CAM standardization for optimization. We have 5 libraries. The first was as you can see on the screen, is our virtual machines and clamping devices. The second is our cutting tools, probably one of our most important. We have our feature library. We have machining cycles attached to this feature library, and we have machining processes. And all of these feed together, they all work together to give us these intelligent manufacturing processes. And in there, we can use things like our color schemes, we can use layering information, variables, and conditional statements. So our CNC processes for intelligent manufacture, how does this work? Well, our 5 libraries are our knowledge base, as you can see at the top of the screen here. Now, when we import a CAD file, we apply this knowledge base to it with maybe our feature libraries, our machining cycles, which are attached to them. We can apply a machining process, and we can output NC code for our efficient cycles and collision-free toolpaths. Our libraries as well can sit on a cloud or server. Okay, this is very important as well if you have even one seat of Tebis or multiple seats of Tebis. Our libraries are synchronized to all of our workstations. So if we have any update to something like the tool library, all of this information gets fed down to each workstation automatically. So everybody's using the same standardized process every time. And I mentioned earlier about the tooling library. So what's unique about this? So the tooling library allows us to optimize our processes. So in here, as you can see, we're able to control not only our speeds and feeds for spindle speed standard feed rates, but we can also add things like our plunging feed rates, our ramping feed rates, our cornering feed rates. We're even able to put in our recommended step overs with the AE values, the AE max for our maximum contact width of the cutter to avoid full width engagement, and also our AP values, which are recommended depths of cut. And all of this as well controls our cooling, so we can have our air blast, we could have coolant if we require it. Now again, this is very, there's a lot of information in here, it's very unique because also we're not only able to optimize via the tool type, ball, like a ball cutter or an M mill or a torus cutter, but we can also filter the tool material, such as whether it's a high speed steel, whether it's a solid carbide tool. Depending on the machines you have, whether you have large machines or high speed machines, maybe some older machines, the current parameters will be different again. So we can optimize via the type of machines you have. And again, this can be further optimized whether it's a roughing toolpath, a finishing toolpath, and even the material we're going to cut. So there's a lot of information stored in here. This is very important and very unique. When it comes to our virtual machines, I mentioned earlier, this is quite unique in Tebis, and this is because it's used in 3 stages of the process. It's used in planning. We can do planning up front, so we can work out our optimization of where the job sits on the machine bed, for what fixturing is required, what tools are required, what limits we're going to potentially hit. We can understand that all up front. Then when we're creating the toolpath, we use it in the programming stage. So we understand the kinematics of the machine. So you're not going to get a toolpath which is not appropriate in reality, or which is not possible. And then at the end, we use it for verification, checking against the tools, the tool holders, the machine head, and all of anything else in the machine environment. So as you can see on the right hand side of the screen, this is for simulation and collision checking, also with the tool changes, and if you have a machine head which is capable of being changed, thus as well. It supports asymmetrical heads, which are very common in the thermoforming industry for machining. We can interactively control the machine head and table. We're going to be able to multiple setup jobs. You can fill the machine bed up if you wish and optimize the parts between them. We check all the toolpath links with safety checks, and we put all of the machine controls macros into the virtual machine. All of this gives us full collision avoidance, as I said earlier, of the spindle, the cutting tools, the tool holders, machines, and workpiece. And because we put all of the controller information, such as acceleration, deacceleration, the look ahead, rapid rates from the controller into the virtual machine, you're going to get 90% plus accurate machining time estimates. So, the advanced machining strategies, what's important here? Well, Tebis is easy to use. We have both traditional manual interactive or template-driven NC programming. And all of these include things such as 2.5D, 3-axis, 5-axis milling strategies, including roughing and also turn mill. We have the special 5-axis trimming solution, as I mentioned earlier. And again, unique to Tebis is the stop model creation for tooling board. We can create the fixtures automatically through Tebis, and we can check and do automatic machine head collision avoidance. We're able to optimize our strategies and standardize them, and we're able to do multi-part setups. Okay, so we're going to maximize your machining strategy. We're going to standardize and optimize all of your working processes. We're even able to do in-process measurement to check for quality, and all of this is possible with our intelligent manufacturing. So the advanced stop model technology is very easy to use. It's very easy to create, but in the thermoforming industries, If we're not using metals, when we were using hard tooling boards, these sheets are very expensive. We have to cut them off to the right size, otherwise we get a lot of material going into the extraction. So it's more efficient for us, and it's more efficient for our machining if we can control how much material we're putting around the job. And we can do this with our advanced stop model technology. Now, our process standardization and libraries and customization. Okay, I talked about this earlier with our 5 libraries. What we want to do here is optimize and standardize your manufacturing processes. So through Tebis's unique automation, okay, we build your best practices into our libraries. And this is very important because this is not just Tebis's processes. These are your processes. And that's what's important here, that we come and we do a digital twin effectively of your workshop, your machines, your cutting tools, your cutting parameters, the materials, clamping devices, etc. All of this is built into Tebis. Even the way you think about approaching machining your jobs. And all of this is about giving you consistent results and short learning times. So the intelligent manufacturing also uses color tables and layering information. So if you have a set coloring standard for roughing faces, finishing faces, maybe a H7 tolerance hole or a thread type hole, all of this can be given coloring information, and automatically Tebis will put the right toolpath to the right color code. We're able to automatically select cutting tools, machining processes, and machining parameters using defined user variables. So with our feature-based technology, we can have variables when we scan a job. We're able to say, is this what's the range of the hole? That maybe the hole sits in a range of between 10 and 20 millimeters. Tebis will automatically find the right tool to cut the right hole for you. And it will optimize all of your tool directions, tool changes for you, so you get the most efficient machining strategy. Moving on to the next slide. So with all this in mind, what is our daily operation? Well, the daily operation is about putting and organizing our data onto the correct part of our structure tree. As you can see, we have the stock model on the blank layer, the part data on our finished part processes, maybe our features, and any clamping devices. So day to day, you're going to be doing more of an organizational job and then applying process templates. So first demonstration is part automation. So what we're going to be showing in here is the ease of use of the software. It's standardization in the process and intelligent manufacture of smart toolpath templates. It's smart process templates and smart automation templates. All of these using our 5 libraries, which we discussed earlier. So if I swap to the software, we have a part set up here already, but let's just have a look into here to start with, and let's just have a look at the advanced stock, the advanced blocking up of stock material. So here we have all the standard options for creating a part envelope, maybe some part envelopes with profile curves, casting stocks, etc. But what's important for dealing with tooling board is that we're able to use this method of stacking blocks with a part envelope. So if we have a look here, we can start by creating a block from this point to this point. I'm able to drag the block model as I wish to encompass the part, just extending. And then in the Z level, as those of you who use tooling board will know, that we have set thicknesses for the boards, and we can say this is a 100mm thick board, and we create our first block. Okay, so the next one, we add a second block, and then we can alter the sizes again here, like so. And we're able to alter the size around the model for the areas that still need material on. And there's still a lot of material in this area where my cursor is. Maybe we don't want that, so we change to a 50mm block size. and add this in. And finally, we can do another one. And again, around the final part of the block, like so. Transfer, and we have our stock model created. When I press OK, this gives me a cutting list, which we can give to the shop floor, so they can go out and they can cut the blocks to the correct sizes for us. But more often than not, somebody will come in and say that we've got some offcuts. Can we use a block of a slightly different size? And again, this is not a problem. We can just go into our edit mode. If we have a block that's slightly bigger or smaller, we just change the sizes. And we can add the other blocks back in and create a new cutting list. So that's the stock model creation. Now, let's have a look at the NC programming side. So we start up our job manager. And in our job manager, we can have our smart toolpath template stored automatically for us. So one way of doing automation is with these smart toolpath templates that I can copy and paste. They're predefined. They've got our tool and information stored in them. We're using the AE values for this cutter from our tool parameters. So if I wanted to change this tool, automatically my stepovers will be changed for me. And all I have to do is choose which strategies I want for the job. So I can copy this and I can paste this into my operation. I can do the same on my semi-finishing. Maybe we want some 16. Paste these in. Maybe some finishing. Oh, maybe the 12. And finally some remachining. And insert that. So now we've built up our structure from our templates. Now I just apply the data, and I can do this globally using the assign function in Tebis by saying this is my blank, this is my stock model. These are the elements I want to machine, and we can have some protected elements too, in the case it's board or a clamping device, and Tebis will automatically apply the data to these. Let's apply the toolpaths now. In here, this is good. And we can have a look in here now. So we've got the machine head automatically applied. You can see the blank and everything else is already in here. Maybe what we need to do is set all the reference points for everything. Let's again go into our assign function. Set our reference point, and now we can machine. So while Tebis is calculating, we can see that now we're doing the roughing toolpath. It calculates this from the stock model. It'll then look at the semi-finishing with the 16 ball nose tool and do all the vertical areas, as you can see being calculated now. Then we move on to the shallow areas with the 16 mil tool. Then we're on to our 12mm ball nose tool for our steep areas for finishing. And while all this is calculating, this is always using the technology from the machine, which has been defined. In this case, this is a Bellotti machine for model making, It could be any machine that you've got, but all the kinematics from the machine head are stored in the system, such as its maximum and minimum C-axis angles, the A or B axis angles, and all this is taken into consideration all the time as we're producing these toolpaths. So then we'll go on in a moment just to the 12mm ball nose shallow operations. And again, while this is calculating, it remembers what's been machined last time. In the last operation, we're always constantly using the previous toolpath as a reference to where we need to be machining now. As you can see there, now we've got all the shallow operations going in. And what's important here is that all of these templates, no matter where we apply them, they're not rigid. Okay, this is again unique to Tebis, is that these are all very flexible. So if I need to change any settings for any reason, I have the ability to do this very easily in the software. That's what I'm going to be showing you in a moment. And we're just doing finish the remachining, and then the operation's finished. So we have our roughing, our semi-finishing in steep and shallow, finishing, steep and shallow, and our remachining. But let's take a look at this operation. As you can see, I mentioned earlier, this is not rigid. Maybe I don't want to cut the side panel in this way. Maybe I want it to flow cut around. And all I have to do here is just go back into the operation. I have the ability to now edit the areas that I want to machine or want to leave out, such as these. Okay, and then I can change the operation. Now I can create a new operation by saying continue and just change the strategy and apply this toolpath. And there you go, we now have a flow cut along this edge. So you can see we can interactively move into these operations at any time. Now this is good for this is a good way of approaching parts which may be quite different every time, but remember that it's easy to template because we will always follow the same sort of strategies with roughing, some re-roughing, semi-finishing and finishing and remachining. It's always a standardized process. But if we have parts that are fairly similar, okay, it's possible now to apply an automatic machining process to this. And we can do this with our smart process templates. And if I open this up, we have a predefined set of operations ready to go. And if we look in here, on the right hand side, we can see that we have variables in here. So Tebis will automatically select its own geometry in this case. And I will just apply this. And that's all I need to do is just apply it. Tebis will sort the rest of its information out for itself because we've organized the data in advance into the layers as I mentioned in my presentation. And you can see now that Tebis has calculated the roughing toolpath. It's going to do some re-roughing now using the residual stop model from the last operation. All of this again using all of our library parameters from our cutting tools, from our machines, features, etc. We then do our semi-finishing operations. Now we've done the steep areas. And our shallow areas. And now we can do some remachining. in both steep and shallow operations. And then finally, machine some stepped holes which are on the side of the job. And the operation is now finished. So let's just have a look. Some of the things that have gone on here. So we have our roughing and our re-roughing, our steep and shallow operations for finishing. We have some steep areas for remachining, some shallow areas for remachining, and we're able to machine these stepped holes which are in the side of the job here. And if we let's just turn the blank off so we can see it. And what's important as well here, we can see this 6mm remachining operation. If I look at the tool simulation for this, what we can see that we've applied a collision avoidance strategy on this. So as we come to machine it, you'll see that the machine head is moving to avoid any collisions as it moves around the part automatically. For the features, again, this is one toolpath, but this is one intelligent toolpath with 3 different operations in because we have this stepped hole. And if we have a look a little bit further into here, we see we have some features like so. To start with, we have a center drill, and we can go around and we spot the holes. And it's optimizing always the tool direction before tool changes. So it machines the hole, it does a tool change automatically. Now we've got a drilling operation. Like so. And then finally, we're going to change to a flat cutter for machining the large part of the hole out in a helical fashion. So 3 operations in one, all with automation to understand the size of the hole and pick the correct tool automatically. The final way of doing automation would be the full automation, the smart automation templates. And in this, what we're able to do with our job manager is we'll see we have one toolpath, in this case for roughing. And now we can see, if I just move this out of the way, all I'm going to do is say which maximum tool I want. As we can see, we have a user-defined element here saying our maximum tool limit is 50. And I'm going to set our minimum tool down, in this case 20. And all I do is hit apply. Everything else is automatically selected for me. So Tebis will now understand, okay, the starting tool should be 50. It's going to work its way down to a 20mm tool to give us re-roughing operations, all using the stock model, the residual stock model from the previous operation. And as this is calculated, we can see different operations taking place. We have another operation being calculated now. Again, using the previous stock model. And all of this is taken into consideration, all the automation and Tebis issues and all of those factors we discussed before for our cutting conditions. So we can see the toolpath is now finished. We have a look at the tool selection now. We should see in our descriptions that we have a 50mm tool going to a 40, 30 and 20 with 4 different operations, all from one toolpath. And if we look at our simulation, we can see in here that this is my first toolpath with the 50mm tool. There's my 40, all with optimized tool changes, our 30, and going down to a 20mm cutter here. And to show how this can be changed, we can just change the system settings from a 40mm tool now to a 30. And we can just re-execute this toolpath. And what we should see now is 2 tools being selected from 40 down to 30, just with the change of parameters. So we have our main stock roughing now. This will be done with the 40mm tool. And then we have our next operation for the remachining. With a 30mm cutter. So let's have a look in here. In our tool descriptions now we have 2 tools rather than 4. And in our simulation, you can see our first tool path and then our second. This is all possible as well with finishing. In the same manner, we have a maximum tool now of 20 with a minimum of 4. So let's go from a 20 down to a 6mm diameter tool, and we'll apply this. So now we have some steep angles being machined automatically. And the shallow angles, or the shallow areas even, with some remachining. Operation is done. Let's have a look. So in here now, we can see for finishing, we have our 20mm steep, 20mm tool for shallow, our 12 diameter tool for the fillets, and then down to a 6mm tool for the fillets. Again, with our simulation, we can see the first operation for the steep areas. We have the shallow areas, a tool change to a 12mm tool for the remachining, and then down to our 6mm tool for the final remachining operation. And again, finally, we just change some of the tool sizes, maybe a 16 down to a 4. And again, now the system will understand that the 16 diameter tool is the maximum tool diameter to use, so we'll use that for the main finishing operation. For steep and shallow angles, and then it will go on to the remachining, working all the way down to a 4mm cutter. Our tool descriptions then, you can see 16, down to a 12, 6, and then a 4. And again, in our simulation, all from one tool path. Sorry, that was me. We'll just recalculate that. So I just recalculate quickly. Sorry, that was my fault. I pressed the wrong button. Working out our shallow angles. Our remachining. and then we'll just check in the simulation now. So we have our steep areas, shallow areas, going down to our 12mm cutter for remachining, down to our 6, and then also down to the final 4mm cutter. So all those operations in single toolpaths. So that's Tebis's intelligent automation. Okay. Now I'm going to go back to our presentation. And let's have a look at fixture preparation. So fixture preparation for trimming. So the intelligent manufacture, if you like, what we've shown so far would be for creating the tool for this vac forming component. Now, once we've vac formed, we want to be able to fixture it and again, position it on the machine for trimming. And all of this can be easily created automatically in Tebis using our wizard base function. You're able to lay the parts out on a machine, on a board, as you can see in the picture here. And you could use the trimming solution for trimming these parts out. And everything fits together with the slots that are put into the component and the baseboard. We can even add weight reduction in here too. And also we can use the fixture, most importantly, for collision avoidance. And for those of you using this type of method, we're able to use cheaper materials for holding this down. For Tebis' specialist 5-axis trimming features, okay, this is very unique to Tebis again, having a specialist trimming function. This gives you interactive control and optimized toolpath vectors for tilt directions. You're able to interactively use and push and pull on the head to understand which tool vectors and tool approach you wish to achieve. We can automatically update the part with freeform surfaces with curve changes. Okay, this is important. We're able to change and correct paths. We're able to relieve areas where, in particular, where we want to. Maybe change some of the dimensions of some standard shapes. We can create toolpaths on the fly with standard geometry. Okay, we're able to do full collision avoidance automatically again in here with the spindle, the cutting tool, and tool holders. And we were able to produce toolpaths to reduce your tool wear using tool axial movements. And we also have optional reverse post-processing to be able to import historical programs. So lots of companies out there are using teach and learn on their machines. It's important and it's useful to be able to bring these into a CAM system to understand your historical parts and then re-optimize them for the future, should you wish to. And all of this can be further increased with ease of use and safety using Tebis's automation with its intelligent manufacture. So the next demonstration brief is our 5-axis trimming solution. We're going to look at the fixture creation. We're going to look at the standardized process, and we're going to look at the flexibility in Tebis with its interactive control, with its collision avoidance, all using again our 5 libraries. So let's switch back to our software. And now we can have a look at our trimming solution, or let's have a look at, first of all, our fixture preparation. So here we have the surface data for the part we've just machined. Now this would be the vac form data. We're able to now create a fixture for this by selecting the surface data. We're able to then even include different extensions if you want extended surfaces on here. We're able to select things like the stanchion thickness. So in this case, I've set the thickness to be 12mm. If we're using maybe MDF or plywood to produce this part. Again, this is the same for the base plate. And we can also control the ribs and slots that are going to be put into the board automatically for us to fix this fixture together. So let's have a look at it. We'll press start. And what you see now is Tebis has sectioned the part for us. It's produced these stanchions. And in here, you're able to insert more. You can even move them should you wish. At the next stage, Tebis will start to create and section the part for its solid models. And in here, if we wish to, we could create some weight reduction in the part. Maybe if we look here, set our some weight reduction area. And by clicking on the stanchion, we can put holes in it using different shapes to reduce some of the weight. The next stage is the part is laid out. And if I just have a look at my fixture preparation, I could have a board size laid out automatically for me. And in here, what you're able to do, if we have a look from a top view, is you can reorganize the parts to fit on a board. And in this case, we'll probably need two, but let's have a look. We'll move this one out of the way to start with. We can reposition this one. Reposition this one. And make the best use. Maybe we rotate this one around. And move it. And make the best use of our MDF board for creating this fixture. And we could obviously do that for the rest of the parts on the different board as well. Finally, it's asking us to save our information. So let's just do that so we can see clearly what's going on. So I'm going to save my fixture contour here, my volume, which I can use for collision checking. My development sections. And finally, some information to help me set the part up on the machine. Okay. So Tebis has done that for us. So here is our initial contour that Tebis created for the part. We have the part laid out as we wished on the MDF board. We have some setup information for grid lines, and finally the solid model which we can place the part onto and collision check against. So that's the fixture preparation, which I'm sure you'll find useful and interesting. Now let's have a look at trimming. And 5-axis trimming, again, we're going to look at the interactive control of the machine head on this part. So again, I can use smart toolpaths. I have a part already set up, and you can have different types of machines set up in here if you wish. And also your toolpaths predefined as I've currently got. And all I have to do in this case is I pick the curve that I want to trim and the part surface, which is going to give us tool direction. So now we calculate the toolpath, and you can see here we are given all of the toolpath vectors with the part. And if we maybe drag the machine head along, we can see what's going on with this part. And you can see we have some movement in here around the corner and at the back. Now what's interesting is probably we don't want a lot of this movement, so we want to try and smooth this out and optimize it. You'll notice here where my cursor is in the bottom left hand side of the screen that the shape has already recognized that this is a contour. It could be a standard shape, and Tebis will automatically try and understand the part that we're trying to cut. we'll move to the toolpath vectors, and we can see here now that we can control the head using its limits. And we see this is our starting position with the B axis at almost 90 and the C axis at minus 96. So if we come along the part, I can set this position as being good, but maybe what I'm not so happy with here is the tool as the head has swung around in this position. So you can see here my C axis should be around minus 80. Maybe we make the change here. So we say, see, we change it to minus 90, and we can also straighten up the B axis to 0. This is possible. It is also possible to push and pull on the head, as you can see, and set this position. Now we'll set a nice transition through the 2 points. And what you'll see now is a nice optimized movement here as we go through the part to here. Okay. The next operation is this area down here. And if I place the cursor on this position, you can see we have some tool change around here. We'll set the B again to 0 and the C to minus 90 and 0. Set this position, and you'll see this is straighten this area out, and we'll do a position here just to interpolate and smooth it out even further. So now the head is maintaining a nice smooth angle through this, and we should see now it maintains here and comes round the bottom corner. Good. So the next thing is we've smoothed the part. Okay, what happens if we want to have a change of curve? Okay, well this is easy. Let's just go to the end of this, and okay, we'll save this. I have a change curve here. Maybe this is something that we've designed in afterwards, and it's also possible then for Tebis to understand this change curve by me selecting it here. So this is what I want to change, and now the toolpath now, as you can see, will move up around this new section here. Good. Maybe we want to reduce tool wear as well, or we want to move the tool away from the job in certain areas. So for reducing tool wear, we can use this path correction again. We can set this position here. Maybe we set this position as being back to 0. And in between, we want the tool to move in Z in relation to minus 10 millimeters of our tool flute. And you can see now that Tebis will move down the tool and back up again, cutting the part. And we can keep doing that to move in the cutting edge and reduce the tool wear of our cutter. So there's our first toolpath. The next area we want to look at maybe is this slot. So we're able to just copy and then paste our toolpath. We'll just change the elements we want to machine. And we press play. Now you'll see that Tebis has automatically recognized the shape as being a slot. It's going to now treat it as a 2.5D function. So it's going to keep the head in a lock position. And interestingly, what could happen is that we're asked to change the size of the slot. This is all easily changed and done interactively with Tebis. So I can change the slot dimensions if I wish without having to change any CAD data. So 100 millimeters, and we'll change the width to 50 to make the part bigger. And I'm also able, if I wish, to change the position So in this case, we can move in the V direction, maybe 10 millimeters. And also we could rotate this round as well, like so. And there we have our new toolpath automatically for the slot, okay, albeit in the position that we've moved it to. So finally, I want to talk about the reverse post processor. And again, as I mentioned earlier, if we have a teach and learn program or historical program from our machine, we're able to re-import that toolpath or the code into Tebis, and we get a toolpath, or we get a set of curves which look like this. We're able to use these curves now to re-engineer that teach and learn program. So let's copy this and we create another toolpath. And then now what we can do is we'll select this curve as our new cutting edge. And I'm going to change this time to center driven, because this would be the NC points that we've read in. And we can press play and calculate this new toolpath. Now, what's interesting is you can probably see my vectors. My vectors are in the green compared to the red vectors, which were the original teach and learn program. It's possible now to match these. So let's just change this to a contour. And let's match all of these points. So here, all I do is say vector interpolate, and I'm able now to select and the original vector, and you'll see the tool updating. I do the same here, and the tool updates here, here, and maybe we see it a little bit more here. And I can go around the edge of the contour updating this and creating the toolpath in Tebis exactly as it is on the machine, and then further optimize it if I wish. So this is the 5-axis special software for trimming, the special solution. Let's go back to my presentation now. So a little bit about Tebis. Tebis has been around for more than 35 years. Okay, so we're well-established processes and well-established software in the industry, and world leading in CAD, CAM, and MES software. What's unique to Tebis is our process standardization and our CNC programming automation with our intelligent manufacture. And we have world-leading technology for quality, safety, and efficiency. And all of these software solutions are for pattern model making, trimming, mold and die, component machining, and industrial design, and areas for the automotive and aerospace industry. All completely integrated, as you've seen, into the software. So in summary, it's one integrated package for CAD, CAM, CAQ, and MES. We have advanced toolpath strategies. You've seen a special 5-axis trimming solution unique to Tebis. We have increased machining safety with our virtual machine technology. And we have our advanced stop model technology, which we saw earlier. We've seen the interactive wizard for our part fixture preparation, for automatic fixture preparation, and all of our software for milling and trimming using our intelligent manufacturer, with all of our standardized and best practices built into our libraries to give us these consistent manufacturing processes, reduce our workload and programming time, and reduce any training periods. We're able to use the feature-based machining for open and closed data and reduce your workload and ensuring your delivery times. Now, I hope everybody's found this interesting. If you wish to have more information on this, please contact us at the details shown on this slide. And I thank you all for watching, and I look forward to hearing from you in the future.